All right, today and tomorrow we are going to be simplifying radicals. Simplifying radicals. And we're going to use as a rule, we're going to say when a radical is in simplest form, there are no perfect squares. There are no perfect square factors under the radical. When a radical is in simplest form, there are no perfect square factors under the radical. So right now we're going to list some perfect squares. All right. And all right, some perfect squares. We're going to start with 1. 1 is a perfect square. And let's see, when a radical is in simplest form, there are no perfect square factors under the radical. Just put a little comma here and put other than 1. The number 1. Because 1 is a factor of everything. All right, so you don't factor out a 1 when you're simplifying radicals. But if we're listing perfect squares, then we're going to list 1 as the first perfect square. And the next perfect square is 4. And then 9 and 16 and 25 and 36, 49. And hopefully you recognize all these, okay? And all of these numbers are perfect squares. 4 is a perfect square because the square root of 4 is equal to 2. All right. It's a perfect square because its square root is a whole number. Any number whose perfect square is a whole number, or I'm sorry, any number whose square root is a whole number is a perfect square, okay? And you guys hopefully can possibly, if you needed or wanted to, could finish this list. Next would be 81, and then 100, 121, 144, 169, 196, 225. All right, and those are the first 15. And you should know those pretty much by heart. I think most of you do. The 169 and the 196 you may not be real familiar with, but square root of 169 is 13 and the square root of 196 is 14. So those are some whole number square roots. All right, and then we got variable square roots or exponent square roots. And let's list some of these. Exponent / variable square roots, or I'm sorry, perfect squares. Right, that would be something like x squared. And basically what it is, perfect squares, exponent variable perfect squares, are any powers to an even exponent, or any variable raised to an even exponent. All right? And this is because the square root of x squared is equal to x. And x to the fourth would be next, because the square root of x to the fourth is equal to x squared. Let's just say out here, any even exponent. And let's let you write down one more thing first. And then as we progress here a little bit, this should all come together a little bit better and make a little bit more sense. So let's just write here exponent simplest form. Okay, x to the first. In its simplest form, it's just equal to x to the first. X squared. All right. In its simplest form is equal to x. Meaning the square root of x squared is equal to x. All right. The square root of x is equal to the square root of x. Now, here's where the pattern starts. The square root of x to the third. That's equal to the square root of x squared times the square root of x. Now, what you do is you pull out the highest even power under the radical when you're simplifying these variables. So what this ends up becoming in simplest form is x times the square root of x. All right? The square root of x to the fourth in simplest form is equal to x squared. And then the square root of x to the fifth in simplest form is equal to the square root of x to the fourth times the square root of x, which equals x squared times the square root of x. Now, real soon here, you're going to start seeing a pattern. The square root of x to the sixth is equal to x to the third. And the square root of x to the seventh, that's the square root of x to the sixth times the square root of x. And since the square root of x to the 6th is equal to x to the 3rd, this becomes x to the 3rd times the square root of x. Now are you starting to see the pattern? What's going to be next here? The square root of x to the 8th, and what's that going to be equal to?
Square root of x is 7 times square root of x.
8. Look at all the even ones. Square root of x squared was equal to x to the 1st. X to the 4th. Very good. It's just half the power, right? It's half of the power. And then look what happens to the square root of x to the 9th. It's the largest even power that's in 9. So it's the square root of x to the 8th times the square root of x. So that's x to the 4th times square root of x. Now you see in the pattern? Any variable to an even power, its square root is just half the power. The square root of x to the 10th is equal to x to the 5th. So to expand on that, if we did the old dot, 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 we did the square root of x to the 21st. Wouldn't that be equal to the square root of x to the 20th times the square root of x? And what is the square root of x to the 20th? Good. So here's your simplest form for the square root of x to the 21st. X to the 10th times the square root of x. And this is y. All right, so next we're going to do some examples of simplifying or removing perfect square factors, and then we're going to remove variable factors, and then we're going to multiply radicals and simplify. So here's what we're going to start with. This is all going to be simplify. Those are the directions. Or write in simplest form. And we're going to start off with the square root of 160. All right, now when you're simplifying radicals, the best thing to do to make sure you have the largest perfect square that goes into 160 is just start dividing it by 4 and then 9 and then 16 and 25, 36, 49, 64, 81, 100. You're looking for the largest number on the perfect square list that goes into 160 evenly. So if you take 160 and you divide it by 4, that goes 40 times. But take 160 and divide it by 9, and it doesn't go evenly. And then 160 divided by 16, and that goes 10 times. All right? And 16 goes, it goes 10 times. But 25 doesn't go. And 160 divided by 36 doesn't go. And hopefully you know that 49 won't go into 160 evenly, and neither will 164. So 16 is your largest perfect square that goes into 160. So we break this down to the square root of 16 times the square root of 10. And then we simplify this perfect square. So what this simplifies to is, come on baby, is 4 times the square root of 10. That is your simplest form. No perfect squares are left under the radical. There's no perfect square factors in 10. Only factors of 10 are 1 and 10 and 2 and 5. All right, so there's your simplest form. So let's try 72, square root of 72. Square root of 72, again, you start dividing by the perfect squares. 72 divided by 4. 4 goes 18 times. 72 divided by 9. 9 goes 8 times. Hopefully you recognize from this list, I don't know, maybe this 36. You're looking for the largest perfect square that goes into 72 evenly. That's going to be 36. So this gives us the square root of 36 times the square root of 2. And in simplest form, it becomes 6 times the square root of 2. There's your simplest form for the square root of 72. This should be a review. Hopefully it is, because I know y'all did this in geometry and algebra 1. A couple others while we're here. If you have to simplify the square root of 28, the square root of 28 is equal to the square root of 4 times the square root of 7. 4 is the largest perfect square that goes into 28 evenly. So this simplifies to 2 radical 7. Square root of 75. That's equal to the square root of 25 times the square root of 3, which simplifies to 5 radical 3. All right, so you're trying to find, or you find the largest perfect square that goes into 75 evenly, and then how many times it goes, and then simplify. All right, so now we're going to be working with some variables raised to powers. So now we're going to be simplifying the square root. We've got 54. Got n to the 7th. All under the radical. The square root of 54, n to the 7th. The first thing you want to do when you're simplifying this is you want to break it apart. Break apart the number and the variable with the exponent. So we got the square root of 54 times the square root of n to the 7th. Then, individually, simplify these radicals. 54. The largest perfect square that goes into 54 evenly is 9. So this 54 becomes the square root of 9 times the square root of 6. The square root of n to the 7th becomes the square root of n to the 6th times the square root of n. Now you simplify your perfect squares. Square root of 9 is equal to 3. Square root of 6 is in simplest form. The square root of n to the 6th is equal to n to the 3rd. And the square root of n is in simplest form. Now you've broken this thing apart completely. The last step is to put it back together. And what I mean by that is you multiply numbers that are not under the radical, or numbers and letters that are not under the radical. So you can multiply the 3 times the n to the 3rd, and you get 3n to the 3rd. And then you multiply everything that's under the radical. And in this case, you have a 6 times an n, which is 6n. So this 3n to the third times the square root of 6n is the simplest form of the square root of 54n to the 7th. Let's try that again. Let's take negative m times the square root of, what do we got? 80m to the 9th. All right, so step 1, break everything apart. That's going to be negative m times square root of 80 times square root of m to the 9th. Factor everything under the radical, but don't forget about this negative m right here. All right, bring it down. So we got negative m. We got the square root of 80. 80 divided by 4. 4 goes 20 times. 80 divided by 9 doesn't go. 80 divided by 16. 16 goes 5 times. So the square root of 80 simplifies to the square root of 16 times the square root of 5. The square root of m to the 9th. We're going to pull out the largest even factor. So we got the square root of m to the what? Good. M to the 8th times the square root of m. Now, this square root of 16 just becomes a 4. This square root of m to the 8th, that's m to the 4th. And now we're going to combine, or we're going to put everything back together. So the first thing we got is this negative 1 in front of the m. This negative 1 in front of the m times the 4 gives us a negative 4. And then we've got an implied m to the 1st times m to the 4th, and we get an m to the 5th. And that's everything that's not underneath the radical. And then we handle what's underneath the radical. And that's a 5 times an m, which is 5m. And there's your simplest form. Yes, sir. She's not here. No, sir. Okay. All right, so any questions on simplifying either of those two? All right, then the last type of problem you're going to see today will look like this. We got a 2 times the square root of 7t times 3 times the square root of 14t squared. And now looking at this individually, the 2 times the square root of 7t, that's in simplest form, and the 3 times 14t squared is in simplest form. But as a product, it's not going to be. So the first thing you're going to do here is you're going to put this back together, or you're just going to multiply. You're going to take the 2 times the 3, and you get a 6. And then under the radical, we got a 7 times a 14. That's a 98. And we got a t times t squared, and that's t to the 3rd. Now, you go back to what we just did on these previous problems, all right, where we took it apart. And right here, we took it apart. So now, unfortunately, you put it together, but you got to take it back apart. And what you get here is you get a 6 times a square root of 98 times the square root of t to the third. And now you simplify individually. So don't forget to bring down your 6. Your square root of 98, that becomes the square root of 49 times the square root of 2. Your square root of t to the third, that's the square root of t squared times the square root of t. And now you simplify your perfect squares. The square root of 49, that's equal to 7. The square root of t squared, that's equal to t. And now you put this thing back together, meaning you multiply what's not under the radical. So we got a 6 times a 7 is 42 t. And then you multiply everything that is under the radical. And we get a square root of 2 times the square root of t is the square root of 2t. So here's your simplest form for this original problem. All right, let's do one more of those. Let's go with 7 times the square root of 5x times 3 times the square root of 20x to the 5th. All right, so first thing is our 7 times our 3, which is 21. Under the radical, got a 5 times a 20, which is 100. X times x to the 5th is x to the 6th. This will work out very cleanly. This breaks apart to 21 times the square root of 100 times the square root of x to the 6th. Now you can simplify your perfect squares. So the square root of 100 is equal to 10. The square root of x to the 6th is equal to x to the 3rd. And now everything is out from under the radical. So we can multiply it all. So we take 21 times 10 and we get 210. And bring along our x to the 3rd. And there's our simplest form for this product. All right, so any questions on any of those examples that we did today? All right, so your practice for today is going to be on page 623. One through 3. Ten through 33. All right, you got to show all your work. Now, I keep repeating myself on this show all your work, and some of you guys don't. And if you don't show all your work, which means you should be showing the amount of work that I'm showing in these problems. And if you don't show that, then I can't give you credit. So that's just a decision that you guys can make. All right, some of you write down a problem and then you write down the answer. And that's outstanding if you can do it all in your head, but I can't give you credit for it because the answers are on the handouts that I give you. You guys that are e-learners, your work is due at the end of the period. Just like these guys in class, they're putting their work in the basket at the end of class. You should be taking a picture of what you completed and emailing it to me at the end of the class. Not 24 hours, 36 hours, 72 hours, a week later. I'm not accepting it anymore. This assignment is due when the bell rings. 11:44, thank you. So this goes in the basket. Or email a picture at the end of the period. A lot of you guys don't do your work on time. You send it to me and you want credit for it, and I have to do extra work. So I end up doing extra work because you didn't do your work on time, and I'm not doing that anymore. It's too close to Christmas. All right, so if you don't have any questions, you're excused to work on your assignment. And I'm going to end this meeting.